Hi, everyone. Hello, guys. My name is Serhi. I'm a business development manager at Everstake, the biggest one retail staking provider and a blockchain validator. And we're going to start the round two. First of all, I wanna say thank you for being here. We're super excited to see all of these faces here, and we hope you're having a good time. Also, I want to remind you that for a lot of people, being on stage is kind of stressful, so please cheer them up, clap your hands, and let them feel a bit more comfortable. So our second round is related to DePIN and AI, and we're basically going to go through all the same stages, like the debate stage, AVS's presentation, and of course, the knockout round to find out who's going to be the winner of round two. Without any additional hesitation, please welcome Anna, head of R&D at Everstake, who's going to be moderating the debate part, and of course, our debate participants. Please welcome.
Thank you. Hey, hey. Hey, guys.
Hello, hello.
So, my name is Anna, and we're gonna start our debates now. And let me introduce our debate participants. So, the first one is Clemens Swan. He's a global solution architect in a Consensys. Welcome, welcome. Also, it's Amit Kumar, CEO at AltLayer, and Andrew Nicholas Smith. He is a founder and CEO of Versatos Labs. So we're absolutely happy to have you guys here. And would you like to share a short background about yourself before you start?
Sure. I'm Clemens. I'm with DIN, Decentralized Infrastructure Network, and it's a discovery service marketplace that's starting with RPC. So we're able to connect between the different Web3 gateways, such as Infura, and connect to 40 plus providers so that you can benefit from having the smaller providers with decentralized trust. So looking forward to working with foundations to build up more RPC nodes.
Hi, my name is Amrit. I handle operations at AltLayer. We started off as a RAS service, so we make it easier for people to deploy rollups. But very recently, we also launched a new framework that we call Restake Rollups, which brings different kind of AVSs that could complement the way rollups operate today. So for example, decentralized sequencing, faster finality, and the like. So we have about 5 AVSs live right now. We also have a pretty cool tool that we call Visit, which allows people to deploy AVS in a matter of clicks. So you don't have to worry about all the on-chain components that needs to go there. We'll handle that for you. So if you're building AVSs, come and talk to us. We can help you get to market quite quickly.
I'm Andrew. I'm the founder of Versatos, and we're building the first public fog compute network. Fog compute is effectively the middle ground between cloud and edge. So you bring cloud-grade hardware closer to the edge, deliver cloud scale with near-edge latency, and improve a lot of use cases that need high-powered compute but need near-edge responsiveness. And we're building it as an AVS.
Yeah, thank you so much. Thank you for such impressive background, guys. So regarding our debate topic today, it should be about risk-taking risks, so the slashing and centralization concerns in multi-AVS ecosystem. We're gonna make it like a free discussion type, and to start seeing and share our thoughts on the point that the risk-taking ecosystem expands a lot last time, and a significant interest has emerged around slashing risks and about operations across multiple AVSs, especially in AI and DePIN sector. So operators that secure multiple AVSs here at one time, could observe a growth of slashing risks and concerns of compounded losses that could emerge if these risks will not be managed properly. So let's have a deep dive and a balancing act of ensuring security while management these risks effectively. So who wanna be the first? Maybe Clemens, would you like to share your thoughts on this?
I could just give like a high level just comparison first. There's beacon chain staking kind of in the early days to move into proof of stake. Thinking about slashing in that space, it's really just to prevent the type of negative behavior like double signing or any type of misalignment with regular usage of being a good validator. So if you're offline, things like that. And so when you compare that to AVS staking, you have this restaking layer on top of it. You're taking your rewards from that space and having that inside of the EigenLayer itself, and then you would delegate that to operators. Operators would then run the off-chain code necessary for your specifically actively validated service. So those applications in the AVS store. So when you compare all of that together, yes, there's some centralization. I believe there's around 1,700 operators right now, and there's around 23 to 30 AVSs that are live. And so when we were talking about this before, I was supposed to take the devil's advocate, which is I come from the banking space and thinking about restaking, does that look a lot like reinsurance? Because we've seen this from 2008 with AIG and seeing that space kind of having that centralization risk because there was a lot of real estate in the background leading to kind of bad loans. So is that similar? Is there some type of risk there? Because now we have a value at risk where you're taking your staking rewards from ETH1 and that security, and then you also have that in ETH, in this kind of Eigen space. So looking forward to debating that with
I mean, I have many thoughts on this. So first of all, I think if you look at, the Lagrange guys were here, and he very specifically mentioned that when you run Lagrange, you're an operator for Lagrange, there's no slashing risks in the sense that the net operators are basically creating ZK proofs that goes on chain and gets verified. And because of that cryptographic security, you don't actually need economic security in that sense, right? And so you would still need a variety of operators to come and support Lagrange, but not necessarily for security, but mostly for liveness, right? And so that's one thing that I want to highlight, right? Then there are other components, for example, Automata are building tools around and solutions with TE, so trusted execution environments. And so there are certain kinds of solutions or AVSs. For example, let's say you have an AVS that requires some sort of a double spend kind of detection, right? And the system, let's say, breaks if you try to double spend or try to double sign in some way, doing equivocation. And that, in a way, it cannot be solved by ZK, but it can be solved by something like TE. And so if you are building, let's say, an AVS that has some sort of an equivocation angle, it could entirely be removed by using TE. And so then again, the slashing risk goes away because the TE gives you the guarantee that the system simply cannot double sign, right? And that could have that prevention mechanism. Now, going beyond that, initially when we were, a year ago, when people were saying that, there's a lot of FUD going on EigenLayer because everything, even if you, so in EigenLayer you have this, an operator is either all in or not in, or zero, right? So you have to put all your stake in to secure the system, essentially. And so the idea was that if you are sharing that 100 ETH across all AVSs, if you get slashed one place because the AVS just does everything, something wrong, it has a cascading effect across all the AVSs and eventually on Ethereum. But in the recent design...
That's not the case anymore.
Exactly, that's not the case anymore. And so that idea that, there will be a cascading effect across the AVSs, that goes away with the newer proposal that EigenLayer came up with, where this idea of...
Siloed.
Exactly, you have silos. So you say, and by the way, you could go complete degen in this model where you say, if let's say I'm bringing 100 ETH as an operator, you can decide how much you actually want to get slashed, or up to what percentage. And yes, you can set it to 0% if you want it. I'm not sure if people will like you for that, but at least there's a possibility that you can set to 0%. Then again, everything boils down to liveness, which is very difficult for to slash essentially, because it's very difficult to say, are you not live because you are malicious, or are you not live because the internet has gone down, right?
And so to that point, and like our whole model is around proving liveness because of what we're building. That's like the main thing that we want to be able to prove. And so our model is when we slash for liveness, we're using that to then repay the customer, right? So it's sort of like a built-in SLA. I think that most of the concerns around rehypothecation are eliminated by the silo effect. There is still like this slight concern around, okay, well, if you have all of these rollups that are running effectively the same client, and there's a bug in one of those clients, and all of them fault at roughly the same time, then you could still have this risk of cascading slashing effects. But I think even in that scenario, you're going to see lots of different market mechanisms pop up around restaking, whether it's insurance models or whether it's, I know that there's a team, I don't know if they're working on it anymore, but that was working on simulating slashing conditions ahead of time so you can ensure that if there was going to be a slashing condition, you wouldn't execute that transaction or verify that transaction. And then beyond that, like there's a huge diversity in the types of slashing conditions that are going to exist amongst different AVSs. It's not like every single AVS is going to have the exact same slashing mechanism where you would have this contagion effect where if one of them failed, the next one would fail, the next one would fail. So with siloed restaking and different AVSs being able to get a different portion of the stake, and combined with market mechanisms and the diversity of AVSs and the types of slashing conditions that exist, I think we've really addressed most of the restaking risks that exist. And that kind of brings us to the other concern, which is centralization concerns. And right now, you mentioned, I think there's like 1,700 operators or something like that. So there's not like a ton of centralization from an operator's perspective, but then what about the stake? So is there centralization in, amongst the restaking providers? And I'd say right now there probably is a little bit of that. There's a handful of really big restaking providers like Swell and Renzo and EtherFi and some of the others. So there's not too many, but eventually as there's revenue and yield being paid out of them, the market will attract more and more restaking providers. They'll have to offer higher yields, maybe even subsidize with like points or their own token, which will bring stake away from their competitors and towards them. And a great example of this is, a little over a year ago, I was sitting at a roundtable in Singapore, and the concern was Lido was about to hit 33% of ETH stake. Well, today it's at 28%. And so the market doesn't want a single entity to control a huge chunk of the stake. And that's despite the fact that even if Lido owned 50% of the stake, they delegate most of that to different operators. So it's not like that's in a single operator's hands. And you're going to see similar mechanisms exist for restaking.
Yeah, and I think EigenLayer is currently at 29%, but I don't think that number is also kind of, it doesn't make a big difference. Yeah, I completely agree that the AVSs themselves can set the mechanisms either from governance or from fraud proofs to do their own slashing based on their own conditions. And I think that.
I mean, one thing that I would like to note is that, I personally believe that the security element of most AVSs will not trigger, for all intents and purposes, like in practical reality, will not happen. Yes, and of course, there's a theoretical chance that something really goes bad, and your operator goes away, and something happens, and you get slashed. But that slashing doesn't happen in most systems today, right? It's
very rare.
Yeah, it's a very rare event, and so even if there's some risk around slashing, that is very minimal in that sense. And of course, with all the unique staking coming, that goes away. However, I do worry that, let's say, if you forget about security for a moment, because let's say now people are exploring, we will ZKify everything. That's not true. But let's assume that somehow a lot of components are either ZKified or TE-fied in some way. Then liveness does not need hundreds of operators, right? So what may end up happening is a scenario where you will have, let's say, a bunch of operators that are some sort of operating in a way that only provides liveness property, and then you don't need too many operators, and so you will have some sort of a centralization that comes from the fact that AVS don't need too many operators. So that's something that I do feel is a potential risk around centralization that comes from liveness.
But wouldn't you argue that so long as there's permissionlessness, that centralization doesn't necessarily, so like a good example of this is, let's say a rollup that has a single sequencer. As long as that single sequencer is not permissioned and controlled, in the event that there's a failure or a fault, you can have a second sequencer step in and bond. And so you may have like a temporary liveness failure, but then very quickly somebody else is going to see the economic incentive of running that. So it's less centralization. It's less that there's few operators and more a question in my mind of whether or not it's permissionless to step in and operate, and whether or not there's an economic incentive to do so.
Yeah, and this is a very good point, because my concern with this is if the system is completely permissionless, you will end up with similar POS systems where we have seen that time and again. Even Ethereum, there was at a time when Lido was at the top, and and it's still in a way at the top. So you will have that risk. And the other thing is like, in a way, of course, if you're thinking about staking, you have restaking, you have this ETH component potentially your AVS token component. And so at some point, you also have to, as an AVS, yes, you want ETH, but also you don't want ETH in a way, right? Because it's not an integral part of your thing in some way. Yes, you're borrowing security, and maybe it's possible that initially your token is not live or your token doesn't have the right market cap, and so doesn't have the economic security, so you want to borrow more ETH, and then eventually you want to phase it out in a way that it becomes like 60-40 to maybe 40-60, right? And then the reason I'm talking about this is because then your incentive becomes very much towards your token holders, your stakers, your people who are coming in, which also kind of removes the ETH part in a way away from the whole system.
Which I think reduces the slashing risks. It reduces centralization
Correct.
risks. Yeah.
Yeah, I would just say the market dynamics will kind of work itself out. I'm sure there's a spreadsheet that they all use that said like, okay, well, I'm running this hardware anyway. This is the amount that I have, so I'm going to stake it here. I'm going to diversify, buy more ETH as necessary to balance out their risk.
Yeah, definitely. Makes a lot of sense, and thank you so much for some such valuable information you shared with us. So let's try to sum up. What will be the main important points we should all put our efforts right now to achieve a success in like slashing, centralization, risks management? What is the most important one from your point of view?
I mean, there's one thing that I would say. I mean, focus on rewards, forget about slashing. I think that would be the message that I think you'll see come more and more often. People won't care about slashing that much. They will care about, okay, where's the reward and where's the reward coming from? And do I have enough?
And if somebody is offering like 20% yield run, like let's not do another Terra 2.0 type situation. So like, but I know this is supposed to be a debate, but I couldn't agree with that more. Like focus on rewards, make sure that you're paying enough to sustain your operators and to sustain your stakers. And I think the slashing risks, as long as you don't have some wild, opaque, difficult to understand, difficult to measure slashing condition, like you will find operators, and you just need to make sure that they're getting paid enough to want to run a node for your system, and you'll find stakers that want to contribute stake to those operators.
I think it's still very early days, so just talk with other architects and mechanism design people to figure out how your design works and partner as much as possible.
Yeah, thank you so much. Thank you so much, guys. So we were wrapping up on this, and we went to our AVSs. Thank you.
Thank
Thank you.
Thank you.
Okay, cool. So now we have 9 AVSs and 9 presentation worth of your attention. And for those of you who recently joined us, I briefly remind the rules. Each representative will have 2 minutes to show his presentation. Then we have a minute for your questions. And then we will proceed to the knockout round, the final round for this part of the event. So I want you to meet on stage our first representative. It's going to be YG, a co-founder from OpenLayer. Please welcome.
Think I might as well spend a night in hell reading Torture magazine and pretend that I'm one of you.
Hello everyone, I'm YJ and we are OpenLayer, the modular authenticated data layer powered by everyone. So I'm YJ. Over than 1 year ago, I was working at Robinhood and working on solving the user data problem. We identified a problem which is centralized data source today is undermining the accessibility and authenticity of the data today. This hinders a bunch of technology innovations. For example, the on-chain developers cannot easily access any public new data feeds on smart contract in a few minutes. For AI companies, there's a massive amount of the data they cannot access or have no way to verify that. User private data, which should be owned by users themselves, is controlled and monetized by centralized companies today. To solve this, we founded OpenLayer last year. OpenLayer is the first modular authentic data layer contributed by everyone and every device. It's decentralized. Anyone can contribute to the network using a laptop or mobile phone with minimum to no entry barrier. It's permissionless. Any data stream can be freely added or consumed by everyone. It's also authentic. Any accessible data can be validated using technologies such as TLS notary to ensure the integrity. So far, we have supported multiple data sources. For example, publicly available data on the website. For example, the real-world assets data, the social data. It could also be the private user data stored in Web2 database today. For example, your shopping history on Amazon or your account balance in a centralized exchange. So we launched as AVS on the EigenLayer mainnet earlier this year in May and have onboarded lots of very important operators and real estate assets so far. So here is our social media. Feel free to follow us and reach out to me if you have any other questions. Thank you so much.
Cool, thanks. Any questions to OpenLayer? Okay, but actually, okay, we got a question. Just a second.
Great talk. So what's the incentive for the data provider? As individuals, can we provide data and what we can get back?
Yeah, that's a really great question. So right now we have two types of incentives. One is from the platform. We have like some points as an incentive for users to contribute. And then on the other side, the users can get some immediate benefits after they provide the data for our data consumers. For example, one of our consumers is working on decentralized social. So as long as you provide your data about your LinkedIn data, things like that, you will have you will bootstrap your profile to a new social platform in a short time. And also there's other similar kinds of the immediate incentives.
Super, great, cool. Right before he might punch
Thank you.
you. Thanks a lot. We're moving forward to our next AVS, and it's going to be Luki Song, Head of Ecosystem and Strategy at Chainbase. Please welcome.
Should I? Hello, everybody. My name is Luki from Chainbase. I only have 2 minutes, so I'm going to wrap around the whole thing. So I will talk about transforming blockchain data into actionable intelligence. This is a little overview of Chainbase. On the left side, it is all the blockchain data to the contribution that's contributed by the community members to manuscript. You will hear manuscript a lot. That is data processing standards. Everything together into this real-time structured AI available and trustworthy data. So we can utilize that for all different protocols and AI initiatives. And together, we can build much better intelligent blockchains, protocols, and dApps. So the reason we see the opportunity is, first of all, we started as a SaaS project. We indexed data, we transformed on-chain data and decoded them. We serve enterprises and we see the opportunities there. We process a lot of data and there's a need for high quality standardized data. So we see the challenge of scaling that infrastructure. The solution, that's the AVS that we're building on EigenLayer. We have the SMCP for data integrity, and we have the off-chain data processing network, everything that's executed on EigenLayer. And we have this incentivization contribution protocol that is more of a knowledge-based economy, data-driven. And that's the result. And we right now just launched mainnet. 15% of the tokens will be given to our operators. 2,000 node operators right now already. We have 7,000 CPUs cores contribute to us. Together, data accessibility, verification, and standardization. Different kind of AVS you have had. Join our mainnet, make the moves with us. There you go, data processing standards. Okay.
Wow, super. Very last second, like in the movies. Do we have any questions here? We don't. We do have.
I think I see a question over there.
Mm-hmm.
So as we all know, data is crucial for the AI, right? Everyone is seeking for the quality data. So you mentioned you're a SaaS platform. You're already doing data processing, cleanliness, and doing all the works. So what's the incentive to use EigenLayer? EigenLayer is just providing economic, tokenomics incentives, right? But as long as you have strong data, like what's the role for EigenLayer in your business?
That's such a good question because first it was a SaaS project, right? And we could not see its scales because we have customized data sets. We need manpower. We need intelligence out there. That's why we open sourced everything, decentralized the whole contribution. We use EigenLayer for the network security so that all the manuscript, all the standardized processing framework can be executed.
Cool. Thanks a lot. Thanks for your presentation.
Again?
No, please, we're not hitting women today. A single one. Okay, thanks. We're moving forward, and the next representative is Mr. Harish Kotra, a developer advocate representing Gaia.
All right, hello everybody. I am Harish. I work as a developer advocate at Gaia. I want to quickly give you an overview of what Gaia is and how all of us individually, once we go back, can launch AI agents, right? What is Gaia? Gaia is a decentralized open source platform that lets anybody launch, customize, and also monetize AI agents fully decentralized, right? And how do we do this? When you launch an AI agent with Gaia, what you get is a REST API server, essentially compatible with OpenAI, and you can call it run custom knowledge bases that you can bring in irrespective of any format, text, CSV, PDF, whatever, right? And you can do all of this in 10 minutes, right? It comes with default quadrant vector database and also prompt and state management, right? Runs on Wasm Edge, so it runs on essentially your local machines like computers or even mobile. Right, and where do we come in with EigenLayer? EigenLayer AVS is going to provide node availability and also monitors the Gaia ecosystem nodes that are continuously running. We have about 200K launched as of now, and through 3 layers, right? One is registration, validation, and also middleware, where registration gives standard identity to all the nodes across the system, irrespective of which knowledge base they have. And the middleware layer is where the continuous health checks happen. And the last one is verification layer, where we detect if the nodes are up or not. They have a 100-block challenge that they go through so that we know that nodes are just not randomly down or going through latency, right? So this essentially helps us do GPU metric validation for the future. And that's where EigenLayer AVS comes into play. Yes, that's it. This is where our devs are. It's not a spammy Telegram chat. Do join if you want to build with Gaia. Thank you so much.
Cool. Thank you. Do we have any questions? Should we pass the microphone to the same guy? No? Aren't you going to ask for the server? Okay. Looks like we got no questions, so thank you.
All right, thank you.
The next representative, as you can see, is Jeremy Hazan, Business Operation Lead from Hyperbolic. Please, welcome.
Hi, everyone. Thank you for having me. So yeah, I'm Jeremy from Hyperbolic, leading business operations. And I'm going to tell you a little bit more about how we can actually secure AVSs through proof of sampling. Basically, really quickly about Hyperbolic, we're building decentralized AI infrastructure, focalizing on 3 core goals. Goal number 1 being the GPU orchestration layer. Goal number 2 is the verification layer, which I'm going to be talking afterwards, and then eventually privacy layer to make sure that basically you can make sure to have the privacy aspect for sensitive data on third-party nodes. So I'm going to be focusing a little bit more on goal number 2, which is ensuring security and verifiability in decentralized AI. For this, there are some solutions, as you can see in here, OPML, ZKML, Consensys. The problem is that the majority of them actually have some problems in terms of overheads, computational overhead. And so we needed to create a system that is the one we created called SPML, proof of sampling, in order to actually make sure that it can be very scalable, but also super secure. So the way that it's functioning is basically making sure that you have the asserter, who's basically doing the task, that will send the results to the orchestrator, that will then decide whether or not, in a random sampling way, will put a challenge to basically make sure that you can check everything. So if it's accepted, then it's perfect, and if not, validators are running different results, and basically we're going to based on the results, see if the arbitration is good or not.
Perfect. Thank you. Anyone wants to ask a question? Actually, I do have a question. Can you please tell me how does this proof of sampling maintain network security without any significant computational overhead?
Yeah, for sure. It's through this random, actually, process, and the fact that AVSs basically needs a system that can regularly make sure that the services are operating correctly without overwhelming the system actually with constant checks. And the fact that it's not in a situation where we're constantly checking, it's basically this random sampling process that actually allows the system to solve this problem for AVS, especially when we're talking about like multiple decentralized networks for the nodes verification.
Cool, thank you. Makes sense. And we got another person. Who's ready to give his best shot, and it's Ram Kumar, a core contributor for OpenLedger. Please, welcome.
Hey guys, this is Ram. I'm from OpenLedger. We're building the data blockchain for AI. And as you know, there are three major pillars for AI. It starts with compute, algorithm, and then data. We're working on the data side. This is a quick architecture of our product. What we do is basically provide a platform on which you can build specialized language models. And how do you start that, right? There is three parts to it. One is the data net, where you collect data. And then there is the model fine-tuning. And the third is the apps that is being built on top of us. Let's assume someone wants to build a Solidity Copilot. They would start with a Solidity data net on top of us. Let people across the globe contribute Solidity data. It could be code descriptions, it could be documentations, it could be the actual code itself that they contribute to us, which is then validated by EigenLayer AVS validators. They run a rule engine, which can be with any of the rules that you can set for collecting data. Once it's validated, the data net repository goes ahead and is fine-tuned using LoRa fine-tuning. We create like models on top of that. And we also provide RAG. And these models then can be inferred by any copilots that's being built on top of it. It could be used by AI apps, services, and solutions as well. And the last part to us is that we provide proof of attribution. Why would a business would trust us and not use, let's say, like a Kaggle or something like that, is because of the attribution. What we do is we provide two proofs as the inference happens. Based on the data that is contributed, we implement something called proof of attribution, where we implement data influence model, and we figure out what is the influence every data point has on that inference. We rank that, and based on that, we attribute to each data point. And using that, you can give rewards. You could, figure out price discovery. And the third is you can know how the model works based on data.
Perfect. Right before you got hit. Okay, any questions from the audience? Oh, yeah.
Hi. How do you prevent data poisoning? Like, so, for example, for Solidity, if I put, in each code snippet that I submit to the dataset, instructions to send money to me, and then you train based on that, and then you generate code based on that, and then.
Yeah. So we have the onus for this for the businesses. Whoever is starting the data net, they have the onus to that. We provide the infrastructure. But there are multiple ways to do that, right? You can set a rule engine. That's where we use EigenLayer AVS. Apart from that, we can use LLM as a judge as well. So we provide that service where you use the LLM itself to actually validate the data. So these are the two ways that we attribute right now. But there could be more ways that will be implemented later on. But as people start using this platform, only then we'll be able to figure out. Any other questions?
Other questions? Looks like not. Thanks. Welcome. So, a golden hour or rather, a golden 2 minutes for another representative. Please don't pay attention to the picture. It was yesterday when she was like a bit tired and not in the best shape. So please welcome Semi, co-founder of Hemera.
Hi, good afternoon, everyone. So obviously I'm not Arthur. He's stuck in traffic, and that's Bangkok for us, I guess. So I'm here I have the honor to present the AVS we built. So very quickly about Hemera, we built a programmable data layer. And now with the AVS, it becomes verifiable too. And our main innovation is the account-centric indexing protocol. We built a transparency AVS, and our design was quite general, so it can be extended to, provide any, to verify any, off-chain computation. And in Hemera's use case, this AVS can help to, verify any end-to-end data integrity. I think let's quickly jump onto the demo. Yeah, so that's it. So if you can see at the top, this is the ACI indexer. So the indexer, pulls data from many EVM chains in real time, and it provides, like at the same time, it also perform data transformation at the same time. So it also, when it indexes a new block, it provides state update to the history transparency contract here, at the bottom. And then the node operator, they can take the information from the transparency contract, and they can, check the integrity of the state update from there. So how they do it? They will just do it, by compare the ACI indexer states with their own, RPC node results. So after they do the integrity check, they can return the signed result to the ACI indexer. So that helps us to, eliminate any potential issues that can cause data corruption in Hemera. Yeah. How can we go back to the last? Sorry about that. So once in a few weeks we launch our, AVS, it can start to, help to support integrity verification for 20 million transaction data that we index from 20 plus chains on a daily basis. As we expand our coverage to more chains, it can even provide more value to support like thousands of developers and, millions of users. And this work has been published on Stanford Blockchain Review just recently, last week, so feel free to check it out. And any feedback will be appreciated. And here's my TG. So yeah, going forward, our product and service will be, supported by, secured by the transparency AVS. So feel free to chat with us. Yeah, thank you so much.
Thank you. Any questions? Actually, I got a small question. Do you have any additional values that transparency AVS can deliver to restaking ecosystem?
Thank you so much. That's a very good question. So as we mentioned, so this transparency AVS is the design was quite general. So I think it has the potential that together with TEE, right, provide the AVS can provide a verifiable compute for any like at high scale and performance for use case like verifiable AI and verifiable machine learning, so that we can start to securely apply results that's generated from AI agents or machine learning models going forward. Thank you.
Okay, thanks a lot. Thanks. Now we welcome the next representative, and it's going to be Ranveer Rana, co-founder and CEO of Witness Chain. Please.
Hey everyone, sorry Ranveer cannot be here, so I'm in his seat. Pankaj from Witness Chain here. I'll briefly introduce Witness Chain and our proof of location with you guys. Yeah. So what Witness Chain does is we build a consensus over physical state. That's the protocols we build. And this consensus on physical state relies on a network of shared security from our watchstars. Any physical state or any physical attribute primarily falls into three categories in our network right now, which is location, connectivity from proof of bandwidth, and proof of diligence to validate the compute of a node. In these three, we believe that proof of location is very critical to any application that touches the physical world. So diving deeper into proof of location, watchstars ping. So take this example, the red dot being a node that has to claim a location. The black watchstars ping this node in a cryptographic manner and measure the delays from the node. These delays are then converted to distances, and then in a Byzantine fault-tolerant manner, they are triangulated over to ascertain if the location claim was correct or not. The best part is that since this triangulation is BFT tolerant, even if the prover is sitting behind a VPN using a proxy or deliberately delaying its network packets, it is able to get detected and cannot lie about its location claim. How is proof of location consumed? The application builders can sort of think of it as an API to consume it. You trigger a transaction on chain. The location proofs are carried out off chain by EigenLayer operators and other watchtower sets. Then the results are posted back on chain for the app to consume. And the number here is incorrect. That's an old number. We have already touched more than 2K watchtowers over last week. So welcome to location-aware future of blockchains. Thank you.
Thank you. Okay, I can see there's no questions. Okay, yeah, I'm gonna use the chance and ask the question. Why did you choose specifically proof of location over the internet instead of wireless?
Wireless has limitations, right? If you are doing it over internet, one thing is that billions of devices connected on the internet can directly start participating. The other thing is that even the Byzantine resistance is more when you have devices connected over internet because they are geographically, globally distributed. If I want to corrupt all the devices on a network built over internet, I have to corrupt all the devices across the globe. But over wireless, they are somewhat like the one in your line of sight, so something within this room, easier to corrupt, whereas something over internet is much harder to corrupt. So that's the reason.
Yeah, makes sense. Thank you. Thank you so much.
Hey guys.
We're almost close to the finish line. And please welcome Devcon, a co-founder of Automata Network.
All right, thanks for the intro. Glad to be back on stage again. Just now I was on a panel at Round 1 hosted by Nader. So I'm gonna talk about what we are building at EigenLayer. We're actually helping rollups to transition to like a stage 2. Quick question, how many of you actually know what stage 2 means over here? Okay, let's like jump into it and solve it. So Vitalik actually mentioned this in a couple of times. For a rollup to qualify as a stage 2, they have to either have a multi-prover or formally verifies your maybe prover system. But apparently, formally verifying a system is not easy. So a more practical way is actually to just use multi-provers that consists of a ZK proof system, a fraud proof system, maybe also a TE proof system that can all be managed by an on-chain like security console. So this is actually the way that we are solving this problem. So right now, if you want to like build a multi-prover with TEs, you actually have a lot of options right now. You have like 2 big existing fraud-proof system, Arbitrum and Optimism, and also you have a lot of like validity proof system that built on top of ZK, either a ZK EVM or based on ZK VM solutions. And of course, you have a lot of TE proof system options as well. You can use any of the hardwares out there, Intel, AWS, AMD, or even NVIDIA, they have GPU. So potentially you could even run some of your proof system in a GPU to just parallelize the effort. So with all this, we are able to just like create a multi-prover AVS because we are essentially creating a stateless network that handles all the proving requests, that forwards all the requests to each of the individual nodes in the network, and all of them will be just running different workloads that like the task owner that submitted. So there has been a lot of traction so far since our launch in May. We actually already have like over 37 like sovereign stakers and also over 70 operators as well. Right now, we already secured over 1.29 million staked ETH. This value will still grow. We will be helping all the rollups to secure themselves. Thank you, guys.
Thank you. Anyone wants to? Yes.
Yeah.
All
right.
Go.
A Q&A. Yeah. Any questions?
Yeah. We got a question.
So it's more like a general question. I'm always curious because all the layer 2s currently using centralized sequencer, right? No matter the OP or Arbitrum. So obviously, multi-provers is a great way to solve the proving issues. But as long as the sequencer is centralized, so we have to trust this, right? Why is no one doing like AVS-enabled sequencer or something?
Yeah.
I'm just very curious.
Good question. I think even on the stage 2 definition, they didn't even really ask for a fully decentralized sequencer. I guess that's the reason. So unless we really add that requirement to maybe a stage 3 rollup, then I guess many people are going to follow that standard. They have to do it. And maybe there will be an AVS running on EigenLayer to do that as well.
Thank you.
All right.
Thank you.
I guess that's it. Thank you, guys.
Yeah, probably. Well, and last but definitely not the least, please welcome EG, co-founder of Infura.
All right, hi everybody. So, why is it that Infura is here at AVS Day? We're here at AVS Day because in Bogota in 2022, we announced that we were decentralizing Infura. We presented our design for the first version of that, which is our federated network. This is sort of the things that we've been working on since then over the last 2 years. A tech stack that allows us to test providers to ensure a specific level of quality, figure out how we're going to implement payments for this, figure out how people are actually going to consume these services, how they would be represented in an on-chain service registry. And so this on-chain permissionless marketplace is now what we're presenting today as we transition over to the permissionless version of the network. And that's enabled through EigenLayer as Infura running DePIN as an AVS. So for the last year, we've been doing all of this traditional business development, sourcing node providers, setting up traditional contracts to secure the amount of traffic or the amount of capacity that's needed to serve new networks that we've added through Infura. If you look at some of those new supported networks that Infura added over the last 6 months, things like ZK Sync, Mantle, and Blast, those are things that are not just powered by Consensys running the infrastructure for that. Now the federated network that we had was being used for running the infrastructure to serve Infura developers and MetaMask users. So with this upcoming EigenLayer integration that's going to go live, this now becomes an on-chain service registry where people can offer their services, consume all of these services, and actually participate without Infura being the one that needs to coordinate and facilitate payment. All right, all good.
Super cool. Do we have any questions here? We don't, but I do have a question. So how will, I'm sorry? We got a question. Yeah. Can we pass the mic?
Hi, EG. Can you give any information about sort of slashing mechanisms or anything like that?
So it's very expensive to run infrastructure to be an RPC provider already. And in the way that we're implementing it, when somebody is an active operator, they're getting paid per like unit of usage. So if there's a degradation in service quality, we're of the opinion that at least to start, we won't implement slashing necessarily, but jailing so that for that period of time, the loss of traffic is already a sufficient loss in revenue that penalizes the operator enough without over penalizing them.
Can I go next?
Yeah, let's go. If it's gonna be fast.
Can you share with us what will be the differences between that and the other RPC that exists today that aim to be decentralized, like
a lot of those other RPC offerings focus on decentralized RPC. We want this to be a permissionless marketplace where we start with offering RPC and then we're going to offer any other Web3 services that fit this model. I'm going to have to fight this guy next.
Thank you.
Oh, let's avoid it. Okay, thanks. So we got all the presentation completed, and now we get to the final part. And I'm asking all AVSs representatives to go back on stage, to get back on stage before the final round. For those of you who don't know the rules, just a quick reminder, I'm going to ask 2 questions. Every single representative will have like a half of a minute to answer all of these questions. And after that, you're going to decide who's the winner, who's the best, who gave more valuable or meaningful answers by scanning QR code and voting. But first of all, let's go to the questions itself. Let's start from this corner. Is it red, blue? It doesn't matter. It's a corner. Okay, this is, for me, it's the most disturbing question, really. How can we manage end users, I mean risk-takers, risks when different types of protocols introduce new slashing risks across multiple AVSs? Yeah, we're starting from
Okay, so at OpenLayer, we definitely identified that managing risks dynamically and also automated reactive response is a high priority. So what we do is we are launching a product together with P2P and Josera to bring the real-time data on-chain. such as the performance of the validator matrix, basically the price spike, the user withdrawal time on chain, so that we can automatically take some mitigation actions according to the on-chain state laws.
Thanks.
So what we do is we evaluate and measure the unique unique sets for the validators. We want to make sure that we understand the security of different AVS so that our operators also are being measured and evaluated based on the AVS they validate for.
I think, should I wait?
Yeah.
Or should I start?
Go for it.
Okay, thanks. For us, each node or each AI agent is isolated, right? Its own identity, right? For us, this is through consolidating the slashing specific to nodes only, so that it doesn't cross-contaminate across multiple nodes, and enabling specialization for each node will be able to reduce these risks for us.
Thank you.
Okay, a quick answer is to build an AVS of AVS to monitor the reputation of each AVS. I think we can use, for example, use the transparency AVS to collect metrics, including like TVL, including the node performance and the slashing conditions for each AVS, right? And to calculate the slashing risk for end users.
Thanks.
Yeah, so, wait. So basically on our end, we are implementing like proof of sampling, what I was talking about earlier. So basically making sure that you have the asserter who is going to be basically giving a result to the orchestrator, and then the orchestrator will be randomly making sure that we can verify the task. And so either it gets accepted directly, or actually it gets redirected to the nodes that will then check for that. So yeah, that's how we manage the risk.
I think we here is an ecosystem, not just witness chain. EigenLayer has already done a good job with unique stake, which means not all stake is at risk for being slashed. As far as operators are concerned, they can implement anti-slashers mechanisms to ensure that they are not putting the staker's stake at risk. And from AVS side, we can provide better monitoring tools for our AVSs to ensure that for operators, it is easy to monitor that their AVS is not misbehaving. So I think as an ecosystem, we can mitigate the risk for the restakers.
I think we are working with EigenLayer on trying to get all the AVS on board to actually put the operators inside the TE so that you can verify whether they're running the operator correctly or not. And in order to do that, you don't have to modify any code, because nowadays you have a lot of TEs that could just support this kind of VM-based approach. So with that, each of the AVS can even be sure that others are actually doing the right thing. So there will be a lot of reduced risk for the users.
Thanks.
I would say three things: education, tooling, and transparency, so that users are actually aware of the risks and really understand what things they're being exposed to whenever a new service is potentially impacting their stake or restake. The tooling is available to alert them if there's anything in particular that's kind of that they need to be aware of and can take action on. And then transparency is things like monitoring and visibility.
Okay, thanks. Now the second question, let's go backwards. What strategies can we adopt to prevent centralization in restaking, especially as more operators handle AI and DePIN protocols at once?
The biggest thing for me with that is financial incentive. Like if the financial incentives skew people towards centralization, I think it's already going to be too big of a problem to overcome. That's a thing that led to centralization in mining pools, centralization in staking pools. If the incentive financially is there, then it's going to trend that direction.
Yeah, cool. Thanks.
Yeah, I think we can set a threshold in terms of how many operators will be opting in for all the different AVSs. Because if you have more centralization, that's definitely gonna broadly introduce more risk to the system. But if we have maybe operator set, which is a new feature that Eigen is trying to introduce, that will help us to break down into even more smaller groups in a way that it can help with the decentralization and therefore reduce the risk.
Thanks.
Yeah, I think one thing is the market-driven forces against centralization. So if an operator is too big, if they're running too many AVSs, it naturally puts the stake it has on more risk. So the market will naturally tend to move away from such AVSs, and they'll be more careful with their due diligence. The other thing is the AVSs themselves can have much lighter processes so that not just big, heavy operators, but everyone in the ecosystem, even the smaller operators can run it. For example, our watchtower barely uses a few hundred MB and is very accessible.
Yeah, so it's a little bit similar for us on what you were saying. So basically, making sure that we can have crypto economic incentives. And so this is the way we're implementing things with our verification layer, basically making sure that we can have a pure Nash equilibrium situation in order to make sure that we can, with the right conditions and the right parameters, prevent centralization and restaking.
I think we can address this problem just by launching more AVS, because when each AVS will have its own special requirement. So, for example, for our transparency AVS, we require multi-chain coverage. As we cover more chains, we will have like higher requirement, and those requirements over time will help to diversify the ecosystem, diversify the operator base.
I think for us, two things. One is providing support for any operator to be able to launch quickly with standardized tooling. So, and also incentivizing specialization rather than saying, okay, we consolidate everything together, so launch a node that can do 100 different things, right? So these two things, I think, will help avoid, centralization and support decentralization.
So now we're talking about centralization, but I would like to say centralization is not always bad. We want to collaborate centralization and decentralization. That's what we're doing. Especially if we're talking about AI, sometimes the decentralization is not efficient. So we'll work with the operators, so we make sure the geolocation actually makes sense. If users are utilizing this tech stack for training AI, we want to make sure the cluster stays closer, but we also have that decentralized vibe as well for the decentralized purpose.
Thanks.
So TLDR, more AVS, more operators, more restaters, more people buying Eigen token, and more people supporting EigenLayer ecosystem.
That's a good one. Okay, thank you. So now is the final part. All the questions are being asked, and now we need to find out who's gonna be the winner of the second round. Please, you have a QR code. Please use your phone, scan it, and give your vote to one of our participants. If you want to place a bet, I can offer lower commission than anyone else. So please come here, and we can make a deal. Okay, looks like Okay. That's quite interesting. We got a leader, but everyone else are pretty close. Okay, it was pretty close at the beginning, but look out now. It might change. What just happened? Just someone took 1% from the second place and gave it to the first one? Okay, looks like we got a winner. Okay, let me count to 10 and oh, okay, that's everything. Okay, so we got a winner. It's Hemera. I want to congratulate you, and you deserve it. You gotta receive this awesome present. I believe it's not your size, but come on, it's still so good. Thank you. Congratulate the champion. Thanks. I believe this is the end of second round. You got two more ahead, as far as I know. And I wanted to say once more, thank you for being here. We appreciate your time. We appreciate you being here. Love to see you again. Have a lovely day. Bye-bye.